Hello everyone, it's Dr. C. In the lecture today, just like to spend a little bit of time with significant figures. We're going to look at counting significant figures, and we're going to look at how to determine the number of significant figures in a mathematical operation, multiplying, dividing, adding, subtracting, that type of thing. So let's just do this by example. So let's look at this first number we have here, 549. All non-zero digits are always significant. Okay, so this would have three significant figures. That simple, the 5, the 4, and the 9. So all non-zero digits all right, pretty simple. All right. What we do have to worry about are these zeros. Okay, and there's really three types of zeros. So let's look at those three types of zeros in the next examples. Here we have zeros that are called interior or captive zeros. Okay, so they're trapped between these non-zero digits. Those are always significant as well. So this would have four significant figures. The 1, the 2 zeros, and the 5, always significant. So these interior zeros, what I also like to call captive zeros, they're kind of trapped in there, but interior zeros are significant. All right, so far, all non-zero digits significant, captive zeros, or what we also call interior zeros, those are significant. Next type of zero, you can see these zeros that precede a non-zero digit. We call those leading zeros. Okay, they're really just kind of telling you where the decimal point is. Okay, those are never significant. Never significant. Okay. Again, they're really just showing you, they're locating the decimal point for you. So this number has the 5 and the 9 that are non-zero. It only has two significant digits. All right. So non-zero, interior zeros, leading zeros. Those are straightforward. Either they're significant or they're not. The next type of zero can be a bit ambiguous, and I'll show you what I mean by this. This next type of zero, these are called trailing zeros. They come after non-zero digits, trailing zeros. Okay? So if there's an implied decimal point there, so we kind of know there should be a decimal point after this zero here, but there's not. Okay? We really don't know if they're significant or not. Okay? And that's where I said it's ambiguous. We can't really tell if they're significant or not. So you might say it's ambiguous. You might say, well, this number has at least two sig figs, but that first zero might be significant. The second zero might be significant. We really don't know. It might be 2, it might be 3, it might be 4. Okay? So what this leads to is trailing zeros without a decimal point. It's not a good way to write the number. Just not a good way to write 2,500 like that without a decimal point, because we really don't know. So what should we do? Well, we should use scientific notation. So that 2,500, if I want two significant figures, I'm going to write this. 2.5 times 10 to the third. Okay? 2.5, that's significant. Two significant figures. If I want 3, I'm going to write 2.50 times 10 to the third. Okay? Now there's a decimal point there. So for trailing zeros, if there's a decimal point, the zeros are significant. So this zero here would be significant. And if I wanted 4 sig figs for 2,500, I'd write 2.500 times 10 to the third. Okay? So the point of all that is trailing zeros, we really don't know if they're significant if there's no decimal point. So don't write the number that way. But if there's a decimal point, trailing zeros, so trailing zeros are significant. If there's a decimal point. And I'm running out of room here, but we'll try to squeeze it in. Sorry about that. Okay, so if there's a decimal point, trailing zeros are significant. So let's go down to E. What do you think about that? There's a decimal point. We have 3 trailing zeros. They're significant. this number would be 5 sig figs. Oh, there we go. Something happened with my computer there. And now we have this number to kind of put two together here. We have leading zeros. What do you know about those? Those are never significant. We have a trailing zero. It's significant if there's a decimal point. Is there a decimal point? Yep, sure is. So the 5, the 9, and the 0 are significant. 3 sig figs. Okay, so that's counting. Not so bad. Let's just review very quickly. All non-zero digits are always significant. Interior zeros are always significant. Leading zeros are never significant. They're just showing you where that decimal place is. And trailing zeros, we should never get into this ambiguous situation. We should never write a number with trailing zeros without a decimal point. And, you know, as we showed here, we can certainly use scientific notation to clearly specify the number of significant figures we have. Okay? All right, now let's scroll down here. And let's look at how we determine the number of sig figs in a mathematical operation. So the first thing you have to do is realize the rules for multiplication and division are different than addition and subtraction. So let's take a look at multiplication and division first. Okay, they have the same rules. Okay, so this problem only shows multiplication, but it applies to division as well. So let's go ahead and calculate out this number. So 5.43, 20.2. Okay, and so I'm just going to write out more digits than I have here. And let me just double check that I did that correctly. Okay, so I got the same number. All right, so how many significant figures should we report in that answer? Okay. For multiplication division, we carry the fewest number in any of the fewest number of digits in any of the numbers present. Okay. So we look at this. This first one has 3. Second one has 3. Remember, interior zeros are significant. And the third one has 5. Okay. So we are going to carry the number of significant figures in any of the numbers there that has the fewest number of sig figs, which is 3. Okay? So multiplication and division is pretty easy. Just look for whichever number has the fewest, that's what we carry. So we're only going to carry 3. Now, since this number is 5 or greater, we're going to round up, and we will write this number as 345. Okay? Not so bad. So multiplication, division, find the number that has the fewest number of digits. That's how many you carry in your answer. Addition and subtraction, however, a little bit trickier. Okay? So let's actually write this out differently. And I'm going to write it like this. 1.1, 15.63, and 0.098. So addition and subtraction is based on the number of digits after the decimal point. It's based on the number of digits after the decimal point. Let me get a different colored pen here. 1.1 only has 1 digit after the decimal point. 0.63 has 2. 0.098 has 3 digits after the decimal point. They're not always all significant there because we have a leading 0, but it has 3 numbers after the decimal point. Okay? So what we're going to do is we're going to carry the fewest digits after the decimal point in our answer. Okay, so let's go ahead and add these together. And let me go back to blue. Okay, so I calculate 16.828, but since 1.1 only has 1 digit after the decimal point, we're only going to carry 1 digit after the decimal point in our answer. And since the number after that 8 is a 2, we're going to round down, and we would write this number as 16.8. Okay. So addition and subtraction, a little bit trickier, because what you'll notice is that 1.1 has 2 sig figs, 15.63 has 4 sig figs, and 0.098 has 2. But yet we end up with how many? 3 sig figs. That's okay. It's based on the number of digits after the decimal point, not the total number of sig figs. Unlike multiplication and division. That one, you just look for the fewest number of digits. That's what you carry in your answer. Addition and subtraction, look at the digits after the decimal point. All right, last thing for this video. What if we mix operations? What if we do a multiplication and then we do a subtraction? Well, you're going to have to apply the rules of multiplication for that, and then apply the rules of subtraction for the next operation. So let's go ahead and do this. So 25.4 times 4.15, that gives us 105, and I'm going to carry some extra significant figures, 0.41. All right? So the best procedure when you're trying to do this is keep all the significant figures in your calculator and then round to the correct number at the end. So I'm going to keep that number in my calculator. But realize that since 25.4 has 3 sig figs and 4.15 has 3 sig figs, I'm only going to carry 3 sig figs in my answer. So I'm going to make a note of that. Or then in this answer, 105.41 for that first part of the calculation. Now I'm going to subtract from that 40.25. Okay? So I'm going to go ahead and write it this way. Okay. Now, here's where it gets a little tricky. 40.25 certainly has 2 digits after the decimal point. But what about this first number? Yeah, we wrote the 0.41 there, but we know we only have 3 significant figures from that multiplication. So technically this number has no digits after the decimal point. So we can't carry any digits after the decimal point in our answer. Are you with me? Okay? Because if I were to round at this step, I would round this number to 105. 3 sig figs. There are no digits after the decimal point, so in my answer when I subtract 40.25, I'm not going to carry any digits after the decimal point either. So I'm going to take 105.41, subtract 40.25, I get 65.16, but remember, I'm not going to carry any digits after the decimal point because this number 105 did not have any, and I'm going to express this answer at 65. Okay, 2 digits. And again, look at what we ended up with. We started with 3 digits in 25.4, 3 digits in 4.15, 4 digits in 40.25, but we end up with 2 significant digits in our answer. That's okay, because we did mixed operations there. We had to do 3 significant digits for the multiplication based on decimal points. Our final answer is 65. Watch those. Those are pretty tricky, okay? And you have to keep track because, again, we really want to keep this entire number in our calculator and round to the correct sig figs at the end, but you need to make a note that that number is really 105, 3 sig figs, with no digits after the decimal point. I'm not going to carry any digits after the decimal point in my answer. All right, I think that's all for this lecture for you guys. Hope it was clear enough. And I will see you in class sometime soon. Take care.